All right. For those of you who don't know me, my name is Tim Lloyd, and I am a security engineer at Checkpoint in the Chicago land area. And today I wanted to give you a demo. Hopefully, you want to accomplish this in 30 minutes or less. But I want to give you a demo of what it takes to deploy security gateways in the Azure cloud. Um, so VMSS scale sets fully managed. It's a beautiful thing, and it's really a lot easier probably than most people think. And there just aren't a lot of demos out there on this. So without further ado, I'm going to jump right into the Azure Marketplace. I'm going to begin because this is a live demo. It's in the production Azure environment, and sometimes it can just take longer to build things there. So I'm going to start by building out an environment. To build Checkpoint CloudGuard Network Security Gateways in Azure, you can just type CloudGuard into the search bar. And then you can find it under Marketplace, and you're going to want to choose CloudGuard Network Security, Firewall, and Threat Prevention. That's going to bring you into our Marketplace template. And we're going to build a scale set. So we want to be able to scale in the elasticity of the cloud. We'll click, we'll choose the scale set. We'll click on Create. We're going to create a scale set of security gateways to protect and provide security for my development environment. So I'm going to have to create a new resource group for this. So we'll click on Create New. We'll just call it Dev. And I'm going to put it in US East 2 because that's where my management server is. And we'll call this scale set just VMSS. So VMSS, and we'll give it a Gaia password. So let me give a password here. Okay, that looks good. And then we'll click next as we walk through the wizard. Initial gateways of 2 is what I'm looking for, and I only want to ever run 2. So I don't need more than 2. It's just a small environment. This is just a demo. I could put a larger number here like 10 and add additional scaling events that would require my scale set to maybe grow to 10 gateways depending on particular environmental variables, but just for the sake of the demo, we'll choose 2. The management name in the following field, the configuration template name, those are 2 pieces of important information. You'll need those pieces of information later for configuring your management server. So you would probably want to write these down, and I'll call that out when we get to that step, but I'm going to call this CP MGMT for my management name. And for my configuration template name, we'll call it CP template-dev. And I'm going to keep the rest of this standard, and we'll click next. All right, so we're going to deploy 8110 gateways. That is the Checkpoint recommended version. We're going to choose bring your own license. I have my own VSEC licensing, and we'll deploy those later. So we'll show you how to use the VSEC licensing tool for centrally managing licenses and auto provisioning them as well. It's pretty cool, pretty easy too. We're going to choose a smaller VM. A D3 V2 is a 4-core. We don't need that much horsepower, so we're going to choose the 2-core version, the D2 V2. So change size, and here it is, D2 V2. You can see that it's 2 vCPUs. So we'll select that. And then I have to put in a password to establish SIC. Messed that up. And then we'll choose next to move to the network settings. I want to do a create new because I want to give this a different name. So we'll do vnet-dev. And for the range, we're going to do, let's do a class C. That's 0-5-24. Oh, there is 5-0/24. How about that? There we go. All right, so that range is good. It doesn't conflict with anything else. And I'm going to assign 16 addresses here. 5-0/28 for 16 addresses for the front end next. And for the back end, we'll do another 16 for the back end. Whoops. .16/28. All right, so now we've got our VNet, we've got our subnet range, we've got addresses assigned to the front end, to the back end. So we'll click OK. And you do have to, you can't leave this blank. So if you don't want to assign a network security group here, you have to click create new and leave none, which is what we're going to do here. So now we just want to review. So a validation is going to occur. Once that validation is complete, we'll be able to click create. So there we are. So we're going to create this environment, and it's going to create a two security group, two security gateways in a 2-node scaling group in Azure. So that's what we're doing. So we are clicking on create, and we will let that bake here in the Azure environment, and we'll come back to this. I would like to, come to this slide here. So this is what we're building. I already have this management server built. So that's here. So here's my management server sitting in Azure. Here's my public IP address. Okay. And what we're doing now, or what we just did, is we've deployed these two security gateways, VMSS 0 and VMSS 1. And as part of that wizard, the VNet will get created, and these front end and back end load balancers will also get created. And this is part of a North Hub, which is part of one of our security architecture blueprints for Azure, which I'll show you a little bit later. But that's what's cooking right now in Azure. One of the things that I want to touch on, I'm going to come up a slide. I want to touch on this point of auto scaling versus traditional clustering. I've seen many customers default to deploying traditional clusters, HA pairs, in Azure because it's tried and true, right? It works great on-prem. It provides stateful failover almost instantly. So just been a great tried and true solution for a very long time, and customers default to this architecture in the cloud. The problem with that is that the API fabric in Azure is responsible for moving the VIP in an HA pair. So when you have an outage, the API fabric will move the cluster VIP from the down node to the live node. The problem is the API fabric is slow. It's not instant. It can take up to 2 minutes. So we've seen customers struggle through this. They go to test the HA pair. Stateful connections get lost. Customers get very unhappy. So it wasn't built for the cloud. However, what was built for the cloud is auto scaling, right? Auto scaling in the cloud makes it possible for you to take advantage of cloud elasticity, the ability to add as much horsepower to a pipe as you're required. So if you're hosting a workload in Azure and you have spiky traffic that increases significantly at certain times, days, seasons, moments, you can configure an auto scaling group to grow with the traffic, so that the auto-scaling group will add additional security gateways to handle the workload. It's a phenomenal solution, and it was built for the cloud. So that's why we recommend, if you're going into the cloud, whether that's GCP, Azure, or AWS, that you would configure auto-scaling groups for your security gateways, even though your instinct might be bent toward an HA pair. Also, just one quick point, we manage auto-scale groups seamlessly through what we call the Cloud Management Extension, the CME. And when I say seamlessly, we establish connectivity and SIC and push policy automatically, so that you can grow a scale group with little to no intervention, and in the cooling period, it can shrink with little to no intervention, while your management server automatically brings those new gateways into its fold, establishes SIC, and pushes policy, hands off. There's a scaling event in the middle of the night, you don't have to worry about it. The management server will handle it. So that's the CME, the Cloud Management Extension. Let's come back to Azure, see how we're doing. Oh, look, great timing. So that deployment is complete. So now you know why I've shown this to you, why we went through the trouble of showing you how easy it is to deploy a scale set. We can go to our resource group. So here's the dev resource group that we created. And you can see that we've got this VMSS scale set. And if I drill in here, I can see my two instances running. There they are, VMSS 0 and VMSS 1. So again, we've created these two next-gen firewalls in Azure, and these load balancers, the front end and the back end. So everything is in place. This VNet is in place. So now there are a couple of more things that we need to do. We need to establish this peering relationship so that the management server can manage the gateways in this Azure VNet resource group. And the other thing that we need to do is we need, I have a service role that I've already created. So I've created, prior to this demo, I've created a management server and a service role. We need to assign that service role the necessary privileges over this resource group, and then assign that service role to the management server so that the management server can manage everything here, and so that it can do everything that it needs to do. So let's go back into Azure. So first, let's establish that peering relationship. So here's the VNet that's part of my dev resource group. If I drill in, I can come to peerings here and see that I don't have anything peered to this dev resource group. So we're going to add a pairing. So we'll call this peer dev MGMT. So the peering from dev to the management network. And it's a two-way road. So we want a peer from management to dev. And we've got to peer it to the management VNet. And then we'll click on add. All right, so you'll see the peering status change to connected here in a moment. It's very quick, doesn't take long at all. And while that's working, we want to now assign our service role the necessary rights to manage everything in this dev resource group. And we do that by coming to access control IAM. And we need to add a role. So we're going to add a role assignment. And it's going to need contributor access. So we'll choose contributor. We'll click next. And now, remember, I told you I'd already created the service role. So we just need to go find that. So we'll click on select members. And then we'll do a quick search here. Tim2 is what it's called. There it is. So we'll select that guy. So Tim2 is selected. And now all we need to do is click next, and then review and assign. So that'll just take a second. There it is. It's complete. So if we come to role assignments, we'll see that TIM2, the service role, now has contributor access. And if we come back to our resource group and we come into our VNet, we can see that we have the peering is now connected. So coming back here, we have the peering. We've given the service role access to everything in this resource group, this dev resource group. Now we need to assign that service role to the CME on the management server. And to do that, we use a command line tool called autoprov CFG. So don't let this overwhelm you. It's a lot of verbiage, I know, but you'll see that it makes sense. So autoprov config init Azure is the command, and everything under here is a switch that gets added to the end of the command. So we're going to initialize the CME for an Azure environment. Remember, here's the management name I told you in the wizard you were going to need to write down. And then your template name, whatever your template name was. -OTP is your SIC password. -VER is your Gaia version. -PO is the name of your policy. Here, the name of the policy is just standard. -CN is your controller name. So we're going into an Azure environment. -SB is my Azure subscription ID. And the last three here, AT, ACI, and ACS are specific to my service role, right? So AT is the directory ID, ACI is the application ID, and ACS is my service role secret key. So what we want to do is we need to run this autoprov config command right on the management server. Now, I've conveniently have it here on a slide. So this is the command right here, autoprov config init Azure with all of the switches that we just went through. So I'm going to copy this, and I'm going to come to my management server. So here's a PuTTY session established over SSH. I'm going to right-click it. Sorry. Sure why that's acting honky. Oh, I see, because one of the quotes is backward. One of the quotes, see this little quote right here? This quote is backward. I'm not sure how that happened. I didn't look at it closely, but here's the proper syntax. Okay, now that we've gotten past that little bump in the road, right? It's a demo, they're never perfect, but it's telling me that the CME is already initialized for Azure. Are you sure you want to do this? You want to overwrite it? And I'm going to say yes. Are you really, really sure? Second time, yes, I'm really, really sure. And now would you like to restart the service? Yes, you do need to restart the service. So we'll give that second, we'll give it a second to restart. And there it is. So it didn't take long to restart. And by the way, you can see that this quote here is backward as well. It's funny how that happens. There we go. Okay, so now that we have initialized Azure on our CME, what will happen is those gateways will begin to appear. So the CME has been configured with autoprov config, and now the CME on my management server at this IP address is going to start polling Azure in that particular gateway. And you can see it's done it. So there is our first security gateway in the scale set, VMSS 0. And you can see that it's automatically established SIC, which is pretty cool. You can see that it's assigned an internal private IP on the subnet that I gave it. And you can see that it's pushing policy. So here comes the policy that I told the template to push, which is called dev. have a policy called dev, and it's pushing the dev policy to my dev gateway. So this is working great. Now, kind of coming back to our diagram. So this is the guy that is entered into the fray. So VMSS 0 is now under the control of my management server, and things are happening to it. And you can see that this health check succeeded. So it's doing the things that it needs to do, which is phenomenal. Now, while that builds out, one of the things that I think we would be good to cover is and here comes the second one, by the way. Here's VMSS 1, and it's going to take, probably less than a minute to complete. You can see that there is no license on this VMSS 0 because I haven't configured central licensing using the VSEC licensing tool. That's something that we'll cover in just a moment. But now that one is coming in, coming back to our architecture, we can see this is the final piece. So I've created the peering spoke. I've given the service role the necessary rights over this whole entire resource group. I've assigned the service role to the management server, to the CME, using autoprov config, this big long string here. And now it's doing its job. It's doing its job. And what we'll do now is we'll configure VSEC. So if I want to come back to my management server, let's clear the screen. I need to turn VSEC licensing on. So simple command VSEC _ LIC _ CLI. Well, I needed to add the switch on. I forgot to. So it's going to try to start it. Then it's going to say, hey, it's not on. So there you go. Command aborted. It's off. So we got to turn it on. So let's turn it, not PM. On. There we go. So VSEC licensing CL will turn on VSEC licensing so that we can use a VSEC license to distribute licensing to our scale set. So there it is. It is on, and to open the menu, I'm just going to type in VSEC LIC CLI, and that'll open the menu. While that's opening, one of the things that we're going to need to do now, when you buy a VSEC license and it gets added to your user center, and you go to create a license file, and you go to license what you've purchased, the user center will build this little license file, and then it'll send you an email with this beautiful string here for the security gateway. This is what you're going to need to finish configuring VSEC licensing. So you need to start with the IP of your management server. So this is the IP of my management server, and copy through the 9, right? You just don't need the quote down the end. So we're going to copy that string. Let's come back to, so you can see in our smart console that our 2 gateways are, the configuration is complete. The only thing they're lacking now is a license. You can see it's not activated. So let's do that now. So we'll come back to our management server, and we're going to add a license. So we'll choose one. And now it wants the license string, which is what we just copied from that email. So we'll paste it in, we'll hit enter, and it's going to start adding the license. So it'll take the license you purchased and create a pool. Now this happens to be a 12-core license. So now I have a 12-core pool of gateways that the CME can begin distributing automatically to what's there. And you can see that it's done it just by this information here. But we'll choose 3 so that we can view the licensing. So let's choose 3, and there it is. So here is the name of my license pool that it created, VE-NGTX. You can see, like I said, it's 12 cores, so 12 seats of licensing. And you can see that I've got 8 left over because it assigned 2 of those cores to VMSS 1 and 2 of those cores to VMSS 0. So now my gateways are also fully licensed. So let's exit out of that. And you can see that it still says they're not activated, but Smart Console, it'll catch up and we'll get green lights across the board. The last thing that I wanted to show you is how do we add a second scaling group to my management server. I also have, in addition to this dev environment, I have a production environment called prod. So what do I need to do to add my production security gateway scaling group to this management server? Well, you can see here's the command. It's autoprov. So we're going to do autoprov. We're going to add a new template, and that is my production template. Here is my SIC password. Here's my Gaia version. And here is my policy name, prod. So I'm going to take this and we'll copy that. And we're going to come back to our PuTTY session, paste it in, and hit enter. Well, it didn't like it again. Same thing. Same thing. So let me grab that real quick. Huh. It's funny how those characters just aren't happy with cutting and pasting from PowerPoint, but here we go. So here's the same command. So we'll hit enter. Would you like to restart the service? Yes. So it's going to stop CME and restart CME. And now what we'll have in the end is a management server with CME configured to manage the scaling groups for my security gateways in my dev environment and in my production environment with central licensing managed from the VSEC Licensing Tool. So if we come back to Smart Console, you can see now my licensing it's okay. And you can see, oh, here comes my prod gateway, right? It's getting configured. And we can click on the licensing tab and see that, I now have this gateway licensed using up to 2 cores. It's licensed until January of next year. So we're good to go. And now SIC has been established with my first prod gateway, and policy is getting pushed. We could also add additional environments. So if we had security gateways in AWS, we can initialize with autoprov config an AWS environment and add it to this same management server so that I'm able to manage multi-cloud environments with the exact same security stack from Check Point. So real easy to use. I think we'll draw this to a conclusion. It's really what I wanted to show you guys today. Hopefully you find this helpful and something that you can deploy into your environments so that you can ensure your cloud resources are secure. Thanks, and appreciate it.